A necessary condition for our inverse function to exist is that our original function is one-to-one over a given domain. In general, trig functions are not one-to-one because they are periodic. To define inverse trig functions, we're going to restrict ourselves to a smaller domain where our functions will be one-to-one. While we'll use these domains to define our inverse trig functions, there are in actuality infinitely many different domains that we can use as long as our function remains one-to-one. Now, given our restricted domain, the graph of each inverse trig function is obtained by reflecting the graph of our trig function over the line y is equal to x. And we denote the inverse trig function also by the prefix arc. So the inverse of sine x is also represented by arc sine x, the inverse of cosine x is arc cosine, and the inverse of tan x is arc tan. The domain of arc sine and arc cosine is from -1 to 1, because the range of sine and cosine is -1 to 1. And the domain of arc tan x is all real numbers, because the range of tan x is all real numbers. The range of arc sine is -pi divided by 2 to pi divided by 2. And the range of arc cosine is 0 to pi. And lastly, the range of arc tan x is between -pi divided by 2 and pi divided by 2. And even furthermore, these are going to be horizontal asymptotes. Before we look at any problems, let's rephrase inverse trig functions. Inverse trig functions are an answer to the question on the screen. What ratio of the sides of a right triangle give a certain acute angle theta? Let's interpret this question geometrically. First, recall the definition of sine theta, cosine theta, and tan theta. Now, also recall the definition of an inverse function. Then, the input values for our inverse trig functions are the ratio of the correct sides of right triangles, and our output value, y, are the corresponding acute angle that determine these right triangles. Pictorially, we can represent each of these inverse trig functions as follows. By the Pythagorean theorem, the remaining side is given by the square root of 1 minus x squared for the sine inverse and the cosine inverse pictures. For the tan inverse picture, we'll get the square root of 1 plus x squared. And note the output of our inverse trig functions is the angle y here of each of these right triangles.